Good afternoon, everyone. It's a really great privilege to have such a big and diverse audience here today. I would like to mention that this is the third eResearch workshop held at the Northwest University, and it's fantastic to have colleagues here from many other institutions, including 22 organizations locally in South Africa. And we've got more than 160 participants registered for the workshop, of which many have only registered on behalf of their group. So many more that are participating. I would like to take the opportunity to thank our speakers right now for their time and for sharing their very interesting initiatives, very relevant for the South African context. And I also would like to thank Tenet and our own IT department for their technical support. So I want to bring to your attention today that the audience consists of people from the research areas, research directors, postgraduate students, research administrators, IT staff, as well as librarians. And it's very interesting to see that it's such a diverse audience who all find this topic of training researchers and research support staff relevant. So I think the big question on all of your minds might be that what is in this workshop for me? What is the next 2 hours going to bring me? And I would like to encourage you to, even though some of the concepts might be foreign, and even though some of the talks might not seem directly relevant to your field of expertise, to keep an open mind as you listen to the presenters, as I can promise you that all these topics are very relevant, regardless of whether you're a researcher or research support staff. I would like to also bring to your attention that we've already been rolling out some of these training initiatives in South Africa. And this is not only a theoretical workshop, but actually really something that is happening in South Africa, of which you can be a part. I also want to say that these initiatives that will be presented to you are open communities and encourage your participation, your contributions, and I can guarantee that you will benefit from participating in these initiatives.
All right, so welcome everyone, good afternoon. I'm here to talk today about software carpentry and a little bit about what software carpentry is. My colleague Tracy Teal of Data Carpentry will be also talking about some of the same things, and we've tried to make our presentations a little bit complementary. But software carpentry is an organization that started way back in 1998 by Greg Wilson and Brent Gorda when they were both at Los Alamos National Lab, and they were trying to teach basic software engineering skills to scientists. They taught it over a full 5-day period. They created some online lesson material, and they started to get support and funding. The 5-day workshop was a little bit much. People's brains were overflowing and full by the end of the 3rd day, and that 4th and 5th day just weren't doing much in terms of people's retention. So they rebooted to 2-day workshops in 2012. And began to train peer instructors. And these peer instructors came from alumni of the workshops. And our teaching pedagogy, we use peer instructors, we have helpers in the room. We're using kind of a type-along pedagogy where people are being supported. They have the software on their own laptops. We have helpers going around the room trying to help them out with different syntactical stumbling blocks and things like that. And we really sort of changed the teaching pedagogy and tried to improve the teaching pedagogy in the workshops. And then our instructional material, we treat it as a collaborative object that we work on globally. So the flagship workshops for software carpentry are collaborated on GitHub, and they're really treated as collaborative objects that people all over the world are trying to improve all the time. And we have a fun, dynamic community of instructors that really enjoy teaching. We take those instructors through a 2-day instructor training, of which ANELDA is planning one in the coming weeks in South Africa. And we train scientists how to teach technology skills with more impact. We're using those pedagogical approaches I talked about, We're trying to take into account the learner's background, the disciplines they're coming from, what they know and what they don't know, and we're trying to tune our workshop to reduce the cognitive load of the learner, to try and make sure that we can get good impact building a mental framework for these tools and how they can be used in that learner's own scientific or research discipline. And we have a culture of giving and receiving constructive feedback amongst our instructors. Our instructors always teach in pairs, and the one who's not up at the podium lecturing or teaching is always trying to read the room, understand what might be going wrong, what's going well, and give feedback. We also solicit feedback from our learners as we go in the workshops, and that's a really great way as an instructor to really tune your workshop as you're teaching. With our lessons, we're trying to do more of this, where we're using this Japanese principle of Jugyo Kenkyu, which is lesson study. It's actively trying to study and improve the lessons and think about your lessons and how they're taught, talk amongst other people who've taught the same lesson, and really try to improve that lesson. So it's the kaizen of teaching, or the continuous improvement of teaching, and it's a technique used in Japanese schools and Japanese education. What we're really trying to do with our instruction is to prepare the unconscious mind, where our lessons are really trying to give learners ways to think about problems that they have, ways that can think about those problems differently, so that their unconscious mind can kind of hack on them. There's been a lot of cognitive experiments about this. Given that we have short time, I won't go into this particular aspect. You want to know more about this. It basically has to do with, if you've seen something done before in a certain way, you are able to apply that subconsciously to your own. And imagine that you can actually solve those problems. And we think about how people go from a novice to an expert. We're preparing the unconscious mind. We're trying to mentor people. We're trying to give them an environment where they can play and tinker through different exercises and challenges. And we're trying to build communities at various scales, local to the campus, regional around your nation, regional between nations, adjacent to each other, and then an international community. We're really trying to build an international community of support for learning these skills, learning new skills, and teaching impactful workshops to help people learn new skills and new tools. We also think of teaching as performance art. So this is a screenshot from the show Whose Line Is It Anyway, which is an improv television show. And we actually had one of our instructor trainings in Australia recently actually brought in an improv comedian to teach the instructors how to, improvise in the moment, in instruction, have fun with it, ways to present topics where you share your enthusiasm and share your passion for the skills, for the capabilities these skills will give you. So what do we teach in our workshops, or how do we teach our workshops? We teach 2 days.
Sorry.
Yes.
It's Rob in Cape Town here. So we're not seeing your presentation, so I don't know if you've not clicked the magic button. Sorry to interrupt, but there's been a couple of messages saying, no, where's the presentation? And you just alluded to. All right. So you just need to click the share button. I think you did it earlier.
Yeah, it looks like the video app is locked up on me is the problem. Yeah, so I have the spinning beach ball of doom. Give me 1 second and I will reconnect to the video app.
Maybe just continue talking.
Okay. Yeah. Apologies for that. Yeah, I can't even get back into the video app. That was what had me confused at the start. So apologies for that. It's just as these things go, a cascade of failures. So we really teach we think about teaching as performance art, like I said. Our workshops are 2 days maximum. They're team taught with at least 2 instructors, like I said before. We use a sticky note system where people can flag with a red sticky note if they need help, a green sticky note if they've solved a particular challenge or problem. We use challenges throughout our instruction in order to reinforce the concepts that we've just talked about. It's not a lecture style, it's very much hands-on. The instructor is standing up at a podium, typing along, explaining the things they're typing as the learners are trying to duplicate it and adapt it. And the challenge is that you really take that to the next level and you try and apply it. Like I said, we have helpers all over the room, and we have a culture of feedback that we use. So in our workshops, over the 2 days, we teach 3 core modules, and we can often swap in a 4th module in a 2-day workshop. But the 3 core modules are the Unix shell, a programming language, either Python, R, or MATLAB are the languages we presently have lessons for. And then we teach version control, usually using Git, but we have lessons for Subversion, SVN, and Mercurial as well. And what we're really trying to do with these is, with the Unix shell, we're trying to demystify the command line. We're trying to help people understand that all those crazy incantations of the command line with spaces and dashes and more spaces and more dashes, and this thing has to be in quotes and that thing doesn't have to be in quotes. We're really trying to help people through the demystification of what that command line environment is, and then it's not really that complicated. It just looks complicated because you're building on top of a few simple rules and principles. We talk about how you can automate tasks across sets of files. So, for example, bioinformaticians with huge numbers of sequence files, how you would run, a sequence alignment across, 5,000 files, things like that we talk through, and how you would build those kinds of loops. We also talk about the shell as a simple interface to all the programs on your computer. Then in the programming language section with either Python, MATLAB, or R, we try to basically give skills in that language to building software the way a scientist would need to, in the sense that they need to know that their results are valid. They need to build complexity, and we try to give them techniques for building that complexity from simple functions that call each other, and they can compose software that way. Then in the version control system, we're teaching usually Git, like I said, and there we're really trying to talk about how you can ensure that you have reproducible results, how you can store the script that made your new derived data come to be, and we also talk about how Git can be used for collaboration at scale. And on top of that, as we work on our lessons online, we work on them in Git, and that is a community reinforcement of the skills around using version control and Git that we try to curate. And so what does Software Carpentry, the organization, do? We coordinate workshops. We coordinate instructors and train instructors. We run workshops. We have mentorship communities for our instructors. And we try to catalyze capacity building at member organizations. We also curate lessons and try to support and expand the culture of collaborative instruction around the world. We've had close to 700 or 800 workshops now, 20,000 learners. We have about 600 instructors, and we'd love to have all of you involved. It's a very open community. We're all about capacity building and creating capacity for institutions to run these workshops themselves and to have supportive communities at various scales, like I talked about, to support new lessons, new ways of teaching. We have organizational memberships that we offer at Software Carpentry, where we we basically can help you get instructor training capacity when you need it. We're working with NLDA to build some ways that is available to institutions in South Africa and in Africa in general. So please talk with me or NLDA in the case that you're interested in building more capacity in this area. And we have about 500 instructors around the world. There's not a ton of them in Africa yet, but we're working on that. And we're very excited to work with you and happy to be here on this call today. That is all I have.
Okay, great. Well, thank you so much. So first, I want to say thank you to Anelda for inviting me to speak today as a part of this series. And she's been a real champion for training in software and data analysis skills there in building a community there. And so I'm going to build on what Jonah has been talking about with software carpentry and talk a little bit about data carpentry. And I'm going to talk about sort of why we are founded, what we're aiming to do, and how we're meeting those objectives and how you can be involved. And a lot of similarities between data carpentry and software carpentry. We're sibling organizations, and I'll be able to be on the line at the end of the call to take questions as well. So data carpentry, we're working to build data skills training to enable more effective and reproducible research. As you are probably aware, our increasing capacity to collect data is changing research and changing science. Not only are we collecting more data, this volume of data, but we're collecting broader varieties of data. So things like our sort of standard tabular data, but we have genomic data, geospatial data, text data, and often we want to combine these data sources and data types, and then the velocity of data that's being created. So if we think about the internet, the amount of data that a lot of these companies are getting every second, but even in our own work, how much more quickly we can sequence things or digitize text is changing the speed that we're getting this data and how we have to deal with it. Data production is increasing. So this is just, again, genomic data, but we can see over time the amount of data that's being deposited in this EMBL database, and this isn't slowing down. So this rate of data production is not going to change as we continue on with research. And so working with this sort of big data, and when we say big data, we mean any data that is more than you're used to being able to work with. So if you used to be able to handle data in a particular tool and now you're getting more data back than you can handle that way, then that is big data to you. And this is no longer the domain of specialists, and it instead is widely done by all researchers. So we can't just count on a few scientists, a few researchers, being able to have these skills to sort of hand our data over to them and have us do the analysis. We need to be able to work with this data when we get it back, maybe not through a complex statistical analysis, but at working on the data management, getting started with the data analysis, understanding what's going on with this data. But people are really struggling to manage and analyze this data, and this is everywhere, right? This is everywhere and in all domains of research. So people are sort of getting their data back from their sequencing center, looking at public repositories of data, and sort of saying, now what? So a lot of times what we say about these workshops, both software carpentry and data carpentry, is that people are motivated by frustration. They have problems they want to solve, and they see a data set or some software development in between them and the question that they want to answer. So the question is, how do we scale data literacy along with data production? And training is really a missing piece between this data collection and data-driven discovery because we need to learn how to turn data into knowledge. And it's not just, us on this call giving these talks. that think that training is important. It's researchers themselves who are really demanding this training. So this is a survey of Bioinformatics Resource Australia, the EMBL there, and they see their biggest bioinformatics difficulties, so in dealing with the biological data, expertise and training, and the most useful thing that Bramble could do is offer training. So 50% of people say this is the most useful thing Bramble could do. That's above funding, access to compute power, or even access to more data. And so very rarely do you see a structure where there's something is more important than funding. So the question is, where does this training come from? And that's what we're all here to address. And so data carpentry workshops in particular are helping to fill the training gap around this data analysis piece. But all of us here, what we're talking about is we're talking about training in the gaps. The challenge right now is that universities don't offer a lot of these courses. Part of it is that it's just harder to change a university curriculum. Part of it is that there's not instructors who can teach these skills because it is a relatively new skill set. And so what we're trying to do is offer training in the gaps so that we can help get people up to speed without you having to wait around for a course at your university. So our goal with data carpentry is to provide researchers high quality training covering the fundamentals and best practices in the full life cycle of data-driven research. That means that we're trying to teach the basic concepts, skills, and tools for working more effectively with data. And right now, our first set of workshops, they're designed for people with little to no prior computational experience. So the bench biologist who just got back genomic data, the social scientist that's looking to work with geospatial data. It's people who haven't had experience working with these data types previously. And our organization, we were founding as a sibling organization in 2014 out of the National Science Foundation biocenters. And it was because we saw across these biocenters, which are centers focused on working with biological researchers, this shared need for training at this level where people are just figuring out where to get started. It is a grassroots training effort in the same way that software carpentry is, and it's developed by practitioners for practitioners. So we're really working to identify the skills and best practices needed in data management and analysis in a given domain. So we're not kind of coming from another perspective. It's really people who are doing the researchers themselves that are identifying the important skills and perspectives. All of our lessons are collaboratively and iteratively developed in the same way as the software carpentry ones. And then we take these materials and we deliver 2-day hands-on intensive workshops. So Jonah already talked a little bit about how these workshops are structured. So they're 2 days, hands-on, qualified instructors. So they're very engaging. So it gives the chance for people to try out the skills. We call the model IWU. So the instructor teaches a concept, we work through it together, and then you try it out as an exercise. So it gives the learners an opportunity to try out the skills and get immediate feedback. So when they leave the workshop, they've had a chance to really try things out, but also to struggle with them and get past some of those early challenges. So we can't teach everything in 2 days, but the goal is to teach the fundamental skills to reduce the activation energy for getting started. We use the same instructor pool as software carpentry. So when Anelda talks about instructor training for the carpentries, it's the same program, same curriculum development strategy. We are focused specifically on working with data, how to manage and analyze data in an effective and reproducible way. I've talked about the initial focus and this domain specificity. So our workshops are domain specific by design. This is because different communities have different data types, but also because when you're learning a new skill, if you can learn it with a data set or a set of questions that's already familiar to you, you're building these new skills on a framework that you already have. And also when you go back to work with your own data, it's similar to the one that you worked with in the workshop. So it's easier to transition from what you just learned in the workshop to working with your own data. So I'm going to show, go to our lessons page and show you at the end, and I'll show you what lessons we have. And then there are strategies for developing new curriculum. So the ones that we've had already have had some initial lesson development, hackathons, enthusiasm for the topic. So James is going to speak about library carpentry. We're talking with them about trying to get that into our curriculum as well. There's discussion about social science, HPC carpentry. So those are all things that we're working on developing. Overall, people are learning things, which is great. So before the workshop, maybe they have sort of low levels or lower levels of data management and analysis skills, and they feel like after the workshop, after just a couple of days, they have higher to much higher levels of skills. And overall, they feel the workshops are worthwhile. So they gain a great deal of knowledge from this workshop, and strongly agree that the workshop was worth their time. So not only is it that people are learning things, but they're excited about what they learned that had a positive experience. And overall, what we want to do, even more than teaching the skills, is to increase confidence in people's ability to work with data and empower them to go on to learn more. So now that they've gotten started, to give this as a sort of a foundation to go on and learn more and work with their data more effectively. Same strategies for getting involved as software carpentry, and we can take more questions about that at the end. But that really involves being a helper at a workshop. So if there start to be workshops in your area and you're interested in becoming an instructor or learning more, volunteering to be a helper, becoming a partner or an affiliate, contributing to lesson development, or you can just request a workshop at your institute if you're interested in having this kind of training at your university. We are guided by a steering committee. This is our steering committee. Software Carpentry has a steering committee as well. And we have some support. We've had some initial support from the National Science Foundation, and now Data Carpentry has support from the Gordon and Betty Moore Foundation. I'm just going to show our lessons page so you know sort of where to look and if you have any questions. So here's our lessons page. So you can see here that we have ecology, genomics, geospatial, and some early social sciences materials. So we have links to all of our different lessons here. So data organization, data cleaning, data management, data analysis and visualization in R or Python. We have cloud computing for genomics because genomics data sets, you need to be able to work with the cloud to be effective. Command line, data wrangling and processing, and then data analysis and visualization in R. Geospatial data focuses on R as well, working with vector data, raster data, and introducing the data type. So you will see that all of our lessons start with the piece around data organization and that data type because good data organization is really the foundation of any good research project and what you can do with that data type. So all of our lessons start with that. So I'll stop here and hand it over to whoever is next.
Thank you very much, Tracy, for your presentation. I'm just quickly going to take the opportunity to show people the Python pad that we are using for questions. I know we are a bit tight for time at the moment, so if you just give me 1 second. So on the screen, you should be able to see the Python pad now. It's coming up now. There we go. So this is a collaborative document where you can, we have put in all the information from today's workshop. At the top, if you can see at the top there, we have asked that people who are still present, if you can just indicate from line 19 onwards that you are still present. I think we might have lost a few people. And then there's some background for these initiatives in South Africa, in the South African context that you might be interested in. Just after that, there's some information about what happens after today. Sorry, I was meant to go through this before the presentation started, but if you are wondering, so what now, there's some information there. There's also space in the Titan pad where you can add information and questions, comments to the various presenters. So from line 46, you can see Jonah Duckles. There's space there for questions, comments. The same for Tracy. So if you have any questions which you do not have time to ask today, you're welcome to put it in the Etherpad. There's a big chance that someone else in the audience might have had the same question. So rather than emailing them directly and not sharing the information, it would be a great idea if you could ask your questions there. And then the presenters have promised me they'll get back to the questions that are posted in the Etherpad after the presentations. And then some general feedback and comments about the workshop. So for those of you who have computers in front of you, you're more than welcome to participate in the discussion through the Etherpad as well. The speakers are also posting links there to, for example, Tracy has posted her links to her slides there if you want to refer to this afterwards. So that's all from my side for now. The next speaker is James Baker, and he was unable to join us in person. So we're going to play a video clip that he recorded for the purposes of this this workshop. So over to the folks in Tenet to get that video clip going.
Okay, hello everybody. My name's James. I'm a lecturer in digital history at the University of Sussex in the UK, and today I'm going to talk to you about library carpentry. So, to give you some background on library carpentry, I'm a firm believer that librarians play a crucial role in cultivating world-class research, and in most disciplinary areas today, world-class research relies to some extent on the use of software. Established non-profit organisations such as software carpentry and data carpentry offer introductory research skills training with a focus on the needs and requirements of research scientists in relation to software. Library carpentry is a comparable introductory software skills training program with the focus on the needs and requirements of librarians and information professionals. In its initial exploratory run, library carpentry was funded generously by the Software Sustainability Institute in the UK. It took the form of 4 3-hour sessions held at City University London Centre for Information Science across 4 successive Monday evenings in November 2015. These sessions attracted 59 participants from 14 institutions in London and the surrounding area. Now, there were some contextual reasons, obviously, behind the reason that I went ahead and sort of developed the idea of library carpentry. The first was that in 2007, the editorial introduction to the inaugural issue of the Code for Lib journal declared that, quote, "This is a decisive time for libraries. Digital services, content and tools have become a part of nearly every aspect of library operations. The digital library is here. If you work in a library, you probably work in a digital library." Now, librarians who work in these libraries have a wide range of roles, and I myself, until September, used to work at the British Library as a historian, working at library, working with the digital collections at that institution. Within many of these roles, it's clear that there's the potential for applying programming and IT skills which allow for the automation of tasks and the manipulation of data. Nevertheless, whilst the digital library has since 2007 fundamentally altered what research libraries do and are for, the integration of software skills into the work of librarians has remained somewhat uneven. As Andromeda Yeltsin notes in her 2015 report, Coding for Librarians, Learning by Example, significant social and political barriers do remain. Andromeda writes, "Many library coders spend a significant amount of time trying to cultivate buy-in, educate their colleagues about technology, or work against siloed organizational structures as they produce inherently cross-departmental work." So in light of these and many other institutional and intellectual contexts and concerns, library carpentry had 3 aims upon its inception. The first was to blend non-library specific software skills training, such as software carpentry, data carpentry, and the programming historian, with existing library-specific programs, such as the British Library's internal digital scholarship training program, which I once coordinated, and data science training for librarians, and to kind of blend these into a public offering aimed at librarians seeking an introduction to software skills. The second aim was to collect some data on software skills in research libraries. It wasn't intended that this would be sort of super rigorous data, but nevertheless collect some information that could sort of help us develop in the future. And the third was to build the foundations for a community model for embracing and sustaining software skills in libraries. So to move on to the delivery of the program of library carpentry itself, the program was aimed at beginners, required no prerequisite knowledge, and was tailored to align with the needs and requirements of librarians. It proceeded somewhat thus. Session 1 covered the basics of programming, so sort of programming concepts in essence. And we had an ignorance amnesty, where we asked people to talk about things that they thought they should know more about in relation to software and programming, and then share with each other. And what we found is there's many things that we all think we should know more about and don't know as much about as we should. And I think that sort of made everyone more comfortable with one another. And then we did an introduction to regular expressions. Session 2 covered the Unix shell, very much in the software carpentry model. Session 3 covered version control in GitHub, again very much in the software carpentry model, but included some work with GitHub pages as well. Session 4 covered cleaning and transforming data in OpenRefine. Now there were 4 overarching themes that were used across the syllabus to kind of bind it together, but also to reinforce learning. The first was command line interfaces, which were used obviously with the Unix shell, but also with the work with GitHub and Git. The second was regular expressions. The third was plain text formats. And the fourth was consistent naming conventions. The syllabus was also built around software tools with strong and diverse user communities, use cases with clear relevance to library practice, and functionality found in multiple software tools. The choice, for example, to offer a session that focused on the interactive data cleanup tool OpenRefine was made not only because OpenRefine is a powerful software tool for manipulating tabulated data that is well liked by librarians, but also because OpenRefine queries are built on both regular expressions and on programming languages. And these then introduce learners to clear, well-documented and well-constructed formatting programming syntax. During the course of these sessions, we also collected a huge amount of feedback from attendees, and there were 3 feedback mechanisms in particular I'd like to talk about. The first took place at the beginning of each session. Attendees at the beginning were asked to self-report their skill level based on the topic at hand, and to do this they were asked to complete the sentence, "In relation to the topic this week, I know ... And they were asked to respond with one of 4 options. That was nothing, a little, lots, and lots and lots. Now, at the beginning of sessions 2, 3, and 4, more than 3/4 of attendees reported knowing nothing about the topic at hand. Attendees were more confident on concepts, so session 1 we were introducing kind of programming concepts, suggesting that there is an existence of a basic set of knowledges in the portion of the library community that attended upon which software skills could be built. The second feedback mechanism took place at the beginning of the 3rd session, the program midpoint. Attendees were asked to articulate ways in which what they had learned might be used in their daily practice. Now, some analysis of these responses shows a strong cluster anticipating using software skills to improve their search capabilities. Concurrent with these are clusters around large data sets and reviewing library data, such as repositories. Attendees also reported anticipating using the skills learned at library carpentry to better understand software-related possibilities in their workplaces. The third feedback mechanism that took place was at the close of the final session. Here attendees were asked to articulate what they might need to pass on to their colleagues the skills they learned at library carpentry. Analysis of these responses shows that time and practice are important requirements to passing on skills learned, and in a way that's not unexpected. A smaller cluster reported needing more worked examples from which they could build their own skills to then pass on to others. Organisational barriers to passing on skills learned were also reported. And these were described in two particular forms. One group reported having insufficient IT permissions to apply the skills developed at library carpentry in their workplace and hence to pass them on. And a second, a more nebulous group, reported that their organisational culture was either unsupportive or lacked the communities they needed to embed software skills in their workplace. Together then, the demand for library carpentry, and I should say that we had 59 attendees across the 4 days, the 4 evenings, but there were many more people we had to unfortunately turn away who found out about it late or wanted to come once the series had started, but we just couldn't accommodate them physically in a room. So together that demand and the feedback we got, drawn, of course, it must be noted, from a very self-selecting audience, I think they point to 3 interesting provisional findings. The first is that librarians both value the acquisition of software skills as part of their professional development and report a low competency in such skills. The second is that librarians report undertaking activities that could be improved by the acquisition of software skills. And the third is that librarians face challenges to acquiring software skills and to embedding those skills in their workplace. Now, the library carpentry pilot may have finished, but this doesn't mean that library carpentry is over. A longer version of this talk will shortly be published as a paper, and I'm currently evaluating as well the short to medium term benefits of attending library carpentry to both attendees and their libraries through semi-structured interviews with attendees. And finally, I'm kind of looking to migrate the lesson materials somewhere where they'll be more sustainable, or at least the adaptations that we made to fit them towards library carpentry are noted in some way that other people can build on them. Library carpentry, for me, confirmed there's a demand, an appetite, and a will amongst library and information professionals to acquire software skills. And it's interesting to note that the materials were already reused and repeated both in Australia and in Norway. And there's been a variety of interests from different stakeholders, including yourselves, about how this kind of program might fit in their local contexts. As these librarians and as software skills are both vital components of world-class research, I see library carpentry very much as a timely, if modest, intervention into the research life cycle. Thank you.
So this presentation is going to be first myself giving an overview of what we're doing, and then Hugh Shanahan will talk in more detail about the particular curriculum that goes into the School of Research Data Science. And I should also mention that the other co-chair of this working group, which is behind the activity, Andrew Harrison, or Harry, he's also on the call. So I'm going to talk about what we're calling the CODATA RDA School of Research Data Science. So this is a collaboration between my organization, which is CODATA, which is the Committee on Data of the International Council of Science, and RDA, which is the Research Data Alliance, which is an international collaboration to advance interoperability and the availability of research data. So we heard a lot, and really nicely, from Tracy about some of the drivers for this, why there are these initiatives like software carpentry, data carpentry, library carpentry, and the activity that we're involved in. So I won't spend a great deal of time on this, but I do want to mention this document, which is an international accord, which was led by the International Council of Science and other international bodies which represent science and other forms of research internationally. So the International Social Science Council, the World Academy of Sciences, and the International Academies Partnership. Those are international organizations which promote science and promote the advancement of science and the infrastructure, the skills, the policies, and in particular the policy for science, which is necessary to advance research internationally. They have come together on an annual meeting called Science International, the first of which happened this year, or rather I should say last year, the 2015, which just finished. And the theme at the first of those meetings was open data in a big data world. And for that, CoData produced this accord, which was agreed and published at the Science Forum South Africa. So it's directly relevant to the participants in this workshop. And that made many of the sort of arguments that Tracy was advancing earlier, that the way we conduct research has been radically transformed by the new technologies of the internet, of data analysis and data storage, and that science systems, science policy, the infrastructure we use, and above all the skills which we have at our disposal need to adapt to that new environment. So this is an accord which we're asking for organizations that care about the way in which research is conducted to sign up to. Because the fundamental argument is that for science to advance, the data needs to be open, and we need to address the policy issues, the skills issues, and the infrastructure issues around this. Now, that accord, among other things, makes the case that science can't advance as it must in this time without increasing the data skills which are available to all researchers and the people that support researchers. So this goes back to the points that Tracy was making in her presentation a few minutes ago. So there's a recognized need for all researchers to have basic and, in some cases, advanced data skills. And this also applies to research support staff as well. And there's been a number of reports. Baron Montz recently at a presentation of the Research Data Alliance said that there was a need in Europe over the next 10 years or so for 500,000 people with advanced data skills. That's in research and the skills and technology economy. And there have been Gartner reports with similar sort of estimates. So this is why in a number of universities all around the world you're increasingly seeing data science courses. But we came at this issue and this challenge from the perspective of what do researchers need to support the research that is increasingly they're needing to do with large data sets and large-scale data analysis. So this is where we came up with this idea of the School of Research Data Science. Now, this is work that we've been doing in CoData for some time. I'm just quickly going to introduce a series of workshops we've been doing over the last few years, and wanted to mention this as underpinning some of this activity, and the idea, very much as with software carpentry and data carpentry, that you can run a workshop in one place, increase the skills and enthusiasm, and then participants in that workshop will say, hey, we want to do this at our institution. So this is precisely what happened in the last few years with some of these CoData activities. We ran a workshop in Beijing, and that was very quickly followed by a workshop in Kenya run by some of the participants at that workshop in Beijing. And similarly, the following workshops in Bangalore and in Jakarta were also run by participants in the previous workshops. So this approach to the curriculum that I've mentioned is based upon the assessment of what skills and competences are required by researchers in the 21st century, addressing the need to access data, to analyze data across a large number of data sets, and also the requirements that they have in their institutions to be assisted by research support staff, whether they're in the library or in IT services. So the starting point is that contemporary research, particularly when addressing the most significant transdisciplinary research challenges, when people are taking data sets from different sources, increasingly depends on a range of skills relating to data. And those skills include the principles and practice of open science, research data management curation, how the data should be looked at after and annotated, competence and ability to use a range of data platforms and infrastructures, and the sort of skills of large-scale analysis that Tracy was mentioning, including statistics, visualization, modeling, and being able to develop to some extent and look after the software needed for this analysis. So we're calling that package of skills and competences research data science, because it's the science relating to research data, how it's gathered, how it's looked after, and how it's used. So in putting together this course, we've identified these 6 components, and Hugh will go into this in more detail, but I'll just mention them here. It's the principles and practice of open science, of data management and curation or stewardship of research data, software carpentry and data carpentry, which we've already mentioned, and I'll go into how we're working with those 2 organizations, looking at data infrastructure, statistics, machine learning, and visualization. So this is just a list of the software, of the curriculum components. Hugh will go into this in more detail, but what we've done here is take, in many cases, existing material, but we've put it together into a 2-week course, which we think, as a result, is more than the sum of its parts. And as part of this broader initiative, we're aiming to create an ongoing series of data science schools, which will happen each year in a given place at the International Centre of Theoretical Physics in Trieste. And that will act as a hub. And then our intention is that students that attend the course in hub, the course in Trieste, should be able to put on similar courses built upon that model at their home institutions. So the courses address a recognized need. The aim is for them to be scalable and global. We have a vision of a pathway to specialization. So what I've just described to you is an introductory course, but we also have plans for more advanced courses which are more tailored for particular research disciplines. And our aim is that this should be sustainable, so exploring funding and sustainability models and how we can manage this hub and node model. And we want it to be accredited and a quality course. And those on the left hand of your screen there, those are some of the partners that we're working with. So the first of these 2-week schools is happening this summer at the International Centre of Theoretical Physics in Trieste. We have funding for some students. There are places for up to 120 students, but we're lowering our targets a little bit because we think that might be too many for the first school. So really success for us will be 60 to 90 students in attendance. The application deadline is 1 week away. And if you are interested in participating, then you can see the link to the Indico site at the International Centre of Theoretical Physics there. That has all the details about the application process. And as I say, there is funding available for students from lower and middle income countries. So South Africa qualifies for that. I'll also mention that also this summer, one of the CoData series, which is going on in parallel with this initiative, is also happening. That has the same deadline, and there's a longer URL with the application process there. That's going to be a smaller school. Actually, I saw earlier, you can probably see on that photograph, Johan van Wijk, who I saw at the CSIR room earlier on video. He attended the school a couple of years ago, so that's being repeated, and Johan can tell you all about that. That has a very similar curriculum, but it's more specialized on remote sensing, Earth observation data, and it's planned around a major conference which is taking place in Beijing on remote sensing and the idea of a digital Earth and big data analysis in remote sensing and Earth observation. So that might be of particular interest for researchers working in that area. So I mentioned we have this vision of an expanding network of schools. We intend to attract to Trieste a number of champions who have a degree of knowledge of the materials, and they will help and assist, act as helpers for the other students, and we will also prepare them with online courses prior to the school. And the intention is that those participants, those champions, should be fitted then to be able to run a similar school at their host institution in 2017. And we have plans for those node schools, discussions with partners in Brazil, India, hopefully South Africa, Indonesia, and Kenya. And as I said, we've got plans for specialized regional schools in social science and bioinformatics, hopefully in South Africa also in 2017. So next steps, repeat there at the information. Please come along to those schools or find out more of them. Comment. Let us know in the question box about the curriculum and approach if you have any comments. I just want to flag. This is a CoData and Research Data Alliance initiative. CoData Research Data Alliance, along with the World Data System, are organising a major conference in September of this year in Denver, Colorado, called International Data Week. That has two parts: a research conference and the Research Data Alliance activity. And for the research conference part, that's called SciDataCon. We've just completed the marking of the session proposals, and the call for papers will be released imminently with a deadline of around the middle of May. So please keep an eye out for that, and that may be of interest to participants in this workshop. Thank you very much. I'll hand over to Hugh, who will tell you more about the specific components of the curriculum in the School of Research Data Science.
Okay. Well, so basically, the school is going to last for 2 weeks. It's going to be introductory. It's going to involve software carpentry and data carpentry, which we've heard about earlier. So do you want to go to the next slide? It involves actually what we have defined it to be research data science as to cover these various topics. So we want to cover in 2 weeks what we think are the kind of key set of skills that all researchers from all disciplines are going to need. So starting from software and data, but going through to machine learning. But what we want to focus on is, in the school, is to increasingly focus on open science and the culture of open science and how to develop that for the new generations of researchers. But we also want to show how to publish data, how to cite data, how to share data. And this comes out of the background to the Research Data Alliance and CoData. So both of these organizations really have this strong emphasis on creating a global workforce that can tap into all this data. So many thousands of people are all kind of working in the same direction. So the schools kind of brings together, hopefully, those skills and then that workforce, and also all the disciplines that will make use of all the data. So hopefully a global comprehensive solution. So can you move forward, Simon? Keep going. Okay, well, there seems to be, so what I'm seeing is, so we've linked together machine learning, high throughput cloud computing. So those are all going to be in the second week. And then quality control, annotation, creative management, publishing data is going to be pretty much covered over both weeks, as far as I understand.
Yes.
My current understanding. Simon, can you move forward? Okay, I can't see what's different about that, and can't see. Okay, so just to give you background, the curriculum is focused on researchers. We based on generic skills that, as Simon's mentioned, basically much everyone needs. What we wanted to do is not just give a theoretical course, but building on what Tracy talked about and Jonah earlier, that these are hands-on practical skills. So people learn by doing, and what they take away is an increase in productivity. And so it's not that we have chosen the skills randomly, so we've had lots of discussions, worked with lots of people from around the world and based this on reports that have come out, but really working with the cutting edge practitioners such as software carpentry, data carpentry and related organizations. So what we want to focus on is open research, which is this increasingly strong driver from the funding agencies and from the community, because increasingly all the data needs to be in the public domain. There's a big problem with science at the moment that a lot of it's not reproducible, and if it's not reproducible, it's not strictly scientific. And so there's a big problem where the funders are saying, well, we're paying for stuff that's not being properly put in the public domain, properly open. And so this means increasingly that the data is central, and so how to publish data, how to extract, how to use data, how to annotate data is kind of becoming central to pretty much all scholarly activity, all research activity. And obviously once you've got the data and doing things with the data, you want to be able to make use of the data. So this outlines week one. So Sammy, can you go to full screen? I'm seeing I'm not seeing the full PDF. I'm seeing the PDF, but I'm seeing all the sort of the sides of the PDF. Yeah. Okay. So Monday to Friday. On the Monday, we focus on open science, open research data. We then move to 2 days by data carpentry by Tracy's organisation, and then 2 days by software carpentry by Jonah's organisation. And then we're still in discussions about what we're going to have in the evenings, but certainly that's the first week. And then we move to much more in the second week, the sort of analytics, the machine learning, the statistics, the informatics, but then to finish again with open science. And so what we want is at the end of this 2 weeks is for students from all over the world to have this kind of common understanding of the way science is being radically altered by this surge of data, and how what we want to focus on is how to ensure open science is a global endeavour. So are there particular aspects of open science where particular parts of the world are going to have different experiences, different responses, because ultimately we want everybody to have the same experience in terms of they're going to get the same data, they should increasingly have the same infrastructure as the infrastructure improves around the world, and ultimately there's an underlying same reality, the scientific reality, so it should be increasingly becoming a common experience we should all have, and so how best to facilitate that and what are the barriers to stop that happening. Okay. And so what we want to add into the schools are these reflective sessions to really get this consensus from the grassroots, from the community, about why this is important. So why do open science? Increasingly it's because it's just a cultural shift. It's becoming, if you don't do open science, increasingly you'll be doing science which is obsolete within a few years because people won't be able to access your data or access your information. So it's going to be a big change in how research is done. And so that focuses on all the aspects of data publishing, of data creation and so on. Simon, can you go forward? And so, as we heard earlier with software carpentry, we're using them for the Unix shell, introduction to R, using Git, which is Git is a version repository software, and then data carpentry, which we heard about earlier. But we're going to work with them on the creating SQL and particular topics with data. And then we're creating new material for this course with colleagues from, several colleagues from Belgium and from the UK on visualization topics linked to data. And then analytics, so involving colleagues working in high energy physics, but also we have a a colleague from Accenture, the organisation based in the United States. So, and then working with colleagues from University of Brisbane and possibly with University of Indiana, computational infrastructure. So increasingly, a lot of analysis is done on the cloud, and so you don't even have the machine in your institution. It just takes place through the internet. So how to tap into this infrastructure, is creating virtual machines to run in the cloud, and so on. And so our whole thinking of this course is to kind of build on excellent models which already exist, such as software carpentry, data carpentry, put everything into Creative Commons, give everything a Creative Commons license. And so the advantage of that is because when people return to their home institutions, they will be able to access the teaching material. And so in the same way as software carpentry and data carpentry have put a lot of effort into making sure their teaching is high quality, that's increasingly what we're going to be moving towards. We want to have our students come to our courses, but then able to go away and to learn how to teach this course, to take it elsewhere, and then that will be then hopefully lead to more people able to teach the course. And so we think this model is a good way to just spread this knowledge as fast as and efficiently as possible, so as to create this global consensus. And so training the trainers is something we'll put a lot of effort into thinking about. So as well as software carpentry, data carpentry, there are organizations, for example, Elixir in Europe, which is a consortium of life scientists, and their peers in the United States, Big Data to Knowledge, and then with H2 Africa through Nikki Mulder, I see who was on this slide earlier, and Goblet, which is an organization for bioinformatics software and training. And then we're having conversations with Jaunt, which is the infrastructures, effectively the cable for the internet, people in Europe. So we're having lots of parallel discussions about how best to facilitate this training to enable to as many teachers as possible to come into existence and to pass on the message. I think that's most of it by now, I think. Yeah, Hugh, were you able to hear that or see that? Or
Yeah, I was able to hear that. I think the last slide should actually just reiterate the link. Does it have the last page should have the link again for the first school, just to reiterate the point that if anybody is interested in the audience who'd like to apply for our first run of these, the deadline for this is April the 18th. That's a week from now. You should be able to see the link for the page for that. There's an online application form. There is a questionnaire we need people to fill out. But otherwise, please feel free to drop me a line if you have any questions.
yeah, we can presumably we're sharing these files through Anelda as well, so Anelda can pass on the
exactly.
PDF and the PowerPoint. So.
Just to note, if you go onto the Titan pad, for this section that's there, there's a link for that talk plus quite a lot of extra materials in there as well. It's a link on Zenodo.
Thank you very much, Hugh, Harry, and Simon, for your teamwork there and for quickly making a plan when technology failed us. I think there's a lot of information in this presentation that might be relevant for people. As you've heard, there are still spaces available for the workshop that is coming up in August. Leaves you with enough time to plan ahead and to get cheap flight tickets. Summer in Trieste, I think it's a place to go to, and then you can learn how to do your research data analysis. So thank you very much to all our speakers for pushing through, and I'm very proud to say that we made it with time for questions.
Okay, I hope everyone can hear me. This is actually a question for Anelda. I want to ask her, what is the status of software carpentry, data carpentry, and library carpentry in South Africa at the moment?
Thanks, Peter. So in the Titan pad, we have indicated some information. We have currently 9 instructors in South Africa. They are all qualified as software carpentry instructors. We are running instructor training from the 17th to the 20th of April here at Northwest University, where we'll be training up 24 more instructors. they can choose whether they want to qualify as software or data carpentry instructors, who will both be usable in the RDA Co-Data summer schools. In terms of library carpentry, it's, as you've heard from James, this is still under development. So if there are people who are interested in becoming part of the library carpentry initiative, please send us an email or indicate that in the Titan pad, which I've also emailed to everyone who have registered. There will be on the 2nd and the 3rd of June this year, there will be a global sprint. It's run by Mozilla Science. And there will be 2 days where people can participate to develop more materials for the library carpentry lessons as well. We are busy organizing that. So 2nd and 3rd of June this year, if you are interested to become involved in the library carpentry material development, please just put your name in the Etherpad or contact us. For any of the other things, if you want to run a workshop, we really encourage you to initiate that. I did put information in the Etherpad. Again, you can find all that information on the software and data carpentry websites, respectively, of how to run a software or data carpentry workshop in South Africa. But you can also contact myself or eResearch. We have a question from Babalola. In terms of will the R material of the lesson material handle information or discuss information that will be relevant for next generation sequencing? I think, Tracy, do you want to handle that one?
Yes. So there is an R module for the genomics data carpentry. I'll put that here in the Etherpad, a link to the lessons. Let me get the right. So if you go to datacarpentry.org/lessons and you go down to the genomics section, there's a lesson on R. So that lesson, or our ecology R lesson. There's also software carpentry also has an R lesson that's geared towards novices. It's using a Gapminder data set, but the one in the genomics lesson is on working with the metadata associated with the genomic data set. Let me just put that in so I get the link.
Thanks a lot, Tracy. Do we have any other questions from the audience? There seems to be no other questions that I can see in either the Titan pad or in the video link. There were some questions asked on the Titan pad. We have addressed those. If you have more questions after the workshop, please feel free to add those to the Titan pad. The Titan pad will be available. It will stay up. We will definitely be checking it over the next few days. So if you have questions over the next few days, you're more than welcome to ask them there, or you can email us directly. No further questions?
And I have a question which is somewhat related to, I know we had that problem, I think there were some network glitches. Wouldn't it just be our luck, right, which cut you off in your prime just when you were introducing everything? What I wanted to get a sense of from the other participants is I think, the biggest meeting we've ever held in South Africa using video. And I hope it was a successful experience. I know we had some glitches. I think we've learned a couple of new things about how to do things, like having a deputy chair in another location just in case the chair's internet link goes down at the crucial moment is one of them. But it's very good to see so many people, and I think it shows the resilience of the system. We've had about 50 people connected, 50 endpoints of different sorts connected. And obviously if we multiply that by the people where we've got multiple people in locations, we must have 150 people on this call, I guess, maybe 100. So I just want to say thank you everyone for taking part and bearing with us while we found out the small glitches.
Thank you, Robin. Thank you very much for your team at Tenet in Cape Town, for my team here at Northwest University.
Yeah, I'm going to say a big thank you to Wesley. I've been away, and he's been doing all the stuff here. So.
Wesley, thank you. You've been an absolute star. Thank you very much to our presenters again, and thank you for participating. And we look forward to hear from you in the near future, about how you think we can take this forward in South Africa. Thanks a lot.
Well, we have to thank Anelda. I mean, she put this all together. Thank you very much for the initiative. This is only the start of bigger things, I think. Thanks, Anelda.